There it is.
There it is. Yes,
Okay.
sir. Hey there, stargazers and astro freaks. I have arisen along with the guys from the club. Ronnie Heron here, the proud host of the SBAU Astro Hour. It's a Monday morning online blog for the South Central California Coast Longtime Astrophysics and Telescope Club, the Santa Barbara Astronomical Unit. I call it 93 million miles of fun in the sun. It's heard from our home observatories once a week, and we just passed, well, we're well into the 3.5+ year mark. And come March, we'll start our fourth year, 11 to noon on Monday mornings. YouTube viewers, you can probably ask questions or make comments, we hope.
No,
SB,
I apologize. I
okay.
can't get any live text there, so the live chat. So
All right,
I'm
forget
not
it,
able to
YouTube
interact
viewers.
with them.
Come to our meetings and ask. SBAU is headquartered out at the Museum of Natural History, and check us out on sbau.org. Come visit us. We just had a great meeting Friday night with Dr. Jen Ito, professor of astronomy and science out at Westmont, where one of our talking heads on screen was located. We're going to introduce the whole gang now. Right after I tell you what we're going to talk about this hour. Looking at some very bright stuff out in the western sky, including something very big. It hasn't happened since I was born, 1946, 78 years. Ooh, Mercury's making itself visible. Venus will still be very prominent. Jupiter rising about 8. It's up there between Taurus's horns. Mars sitting in Cancer, the crab. We're going to check out a variable star called Mira, which I think means look at this or check this out in
Means
Spanish.
wonderful.
Well,
Yeah.
yeah, wonderful,
Oh, is that
wonderful.
what it means? All right. We'll have a first quarter moon in 5 days. The torrid, it's an absolutely torrid meteor shower, has two branches. Wow. Finally, a big but sad giant telescope built for the Great Paris Exhibition of 1900, mostly laid flat, I think. And are we going to see a comet named Atlas burn up in the sun this hour?
No,
Stick around. We're going to have some fun in a second here. Let me introduce you to the gang. Our gang in place, ready to be reelected again, some of them. Jerry Wilson, president, beloved man in charge. Aye, aye, Captain.
Good
Married to
morning.
Pat, married to Pat Forgy and had some good excuses on Friday night for not being there in Farron Hall. She's with the Friendship Foundation or something. Is that what she does? Your wife,
Yeah,
Pat? Bless her heart. Chuck McPartland's on board, SBAU's incredible outreach coordinator, also married to a Pat. Pat McPartland is not only our longtime merchandise manager, trying to get rid of all that stuff in one big long yard sale, but she's our incredible treasurer, who may or may not be treasurer again in January. We have Tom Whittemore on the screen, editor of
Morning.
the newsletter for
Morning.
SBAU, former science instructor out at Westmont, and knew our guest science instructress on Friday night, worked with her. It was a great talk. I'm trying to catch up. Tom's married to Maureen. Tim Crawford, who is an expert on incredible stuff like lenses. I
Expert on
think you're ahead of me on this background cosmic radiation thing. I'm kind of lost, but you're going to catch me up at some point. Tim's married to Karen, and none of the wives watch this show, and we're in a very critical week politically here. We'll
Yeah.
probably know next week who's going to run this country by this time. And we always start the day, gentlemen, with a little levity. And I only got four cartoons from you, but I thought you're going to throw in some past ones or some new ones I haven't seen.
no, four is all we have this week.
Okay,
Sometimes it's a rainstorm and sometimes it's a drought.
well, if you start chronologically, Quantum Cats, or we're going to do, no, this is the
This is
some
clip
artwork.
art.
Nail
That's good.
clipper is looking proudly at its work on the wall. It's got a giant clipping in the sky.
Pretty good.
What it looks like around my couch twice a month. Okay, and here are the cats from hell, which includes, well, I'll see what I wrote down from Schrodinger's kitty cat in the box. We don't even see it there at the top.
Yeah,
And we have de Broglie's squiggly cat. It's got a real back problem.
it's a
Right,
wave
like,
cat.
Yeah, right.
That's a De
what
Broglie
is it, a
wave.
Frady cat? And the Dirac cat, directly at you, a direct hit. It's probably got a quantum entanglement with its reflection or something. And we have the Bose kitties, um, and the Fermi cats. There's three in boxes. I assume you guys, can you run it up so I can see the bottom? There's several down below, I think. There's the Capitas cats below Fermi. Not going to be able to move it. We're stuck at the top of that. That's
No,
Yeah.
I know, I was just
Oh, there we go.
on a phone call.
There we are. There's the Bose kitty cats all in one box. The other three can
Uh-huh.
be used for kitty
Yeah.
litter. And there's three of the Fermis are 3-in-1. We're gonna have to
Okay,
do
now these are the Fermi cats, these are fermions.
Right.
They cannot occupy the same quantum level. So these are atomic levels, they're filled up to here, and then the next level up is empty. This is a Bose cat. These can occupy the ground state, and these are all in the same state. And this would be superfluidity or superconductivity if they're charged.
Einstein didn't buy any of this, did he, at the first? And then there's the poor Heisenberg cat. Oh my God, what's the problem with it?
We're not sure where it
uncertain
is.
They're uncertain where he is.
So Ron, those empty boxes are all set up for kitty litter, I think.
I know that. Well, did they all use boxes in their experiments and their explanations, or was it just
The
because Schrodinger?
energy levels are the spherical equivalent of the square well potential. So
Okay.
it's a spherical version of a box. You start with a box because you can do one-dimensional math with it. And in quantum mechanics and solid state physics, you always try and make the thing simple by first doing it in one dimension, then two, then up to three.
Well, you should see what Chuck McPartland does with his cats at home sometimes. A lot of experiments. They haunt him by walking across. Oh, here's one, the Kapitza cat, above and below the
above and
lambda
below the
point.
lambda point.
Okay, what does that mean?
It turns liquid.
Of course, I knew that. Didn't you, Tim? All right, here we are on Halloween night. They happened to land your ETs from space and went walking around the neighborhood and came back and said, we tried to invade, but they just kept giving us candy for some reason.
Good.
In fact, those might have been kids. Okay, off the mark. Here is a large amoeba-like alien in space checking us out, going, by observing humans, I've determined what they find very valuable. They're all dog walkers trying to get rid of that plastic pouch of poop. And that's what they like. I run into enough of these on the street, guys. I know the dog always comes first.
Right. So Ron, there is in Pale Blue Dot. It's a really, really neat book by Carl Sagan. In the very first pages of it, he talks about what aliens might see if they were to come here. And he imagines aliens going around and just looking at the earth and deciding, what's important here. And so he finally decides that because a vehicle is opening a door and a dog gets out, he says, I guess dogs are the most important things.
I
Maybe the
heard a
vehicle.
similar version where aliens observing from a distance would conclude that the dominant life form is the automobile.
Yeah.
Yeah, you're
Yeah.
probably. I figure with 8 billion people, maybe 1 in 8 of us have a car, and that means 1 billion cars. And at any one time, given the fact that half the earth is dark and half is light, maybe half of those are running. Any estimations on your part? I say this to the doubters of global warming. How in the world can all these internal combustions be going, not even counting the smokestacks and the other things.
Yeah.
Anyway, gentlemen, good to have you on board.
Well, in the book Hitchhiker's Guide, they decided the dominant life form was dolphins. Thanks for the fish and goodbye.
Happy Drake equation and standard time back.
Now, we don't have to follow these talking points.
We have to, or we don't have to.
We
Well,
don't.
you got some good ones always, Jerry.
We do, but before a lot of you guys checked on, Ron was asking, he had seen a YouTube on Homua in the Kuiper Belt.
No, it's Haumea, Haumea,
Yeah.
Haumea, yeah.
Haumea.
And
So
he
you
had
know
some
about it?
really strange, sizes I had never heard before. Can you repeat that?
Yeah, it's shaped like a football. It's out there in the Kuiper. It's a dwarf planet and a pretty good size one. It's 1,300 miles long, 1,000 miles wide, and about 700 miles thick. That makes it somewhere between a shape of an egg and a frisbee. And
And
I
it
saw
was,
pictures of it, and I don't think it was made up.
it has two, no, the pictures are totally made up. It has
They
two moons, two icy moons, and there's
got
icy debris all along its orbit. That's why they call it Haumea. Um, Mike Brown found it, and of course, at this point, he was joking with the IAU, but he said he wanted to call it Santa Claus. And they called it Haumea because it seemed to have formed from a large collision of icy bodies. And Haumea is a Hawaiian goddess of childbirth who, the story goes, she walks along and breaks off like her fingers and her toes, and they become children.
Oh,
Well, my understanding from the video was it got its shape because of centrifugal force. It's spinning.
Yeah, well, that's the rapid rotation gives you those ellipsoids.
Yeah, we got a little bit of bulge in the Earth, and I imagine Jupiter, as big as it is, has a slight bulge with 10
And
hours.
1,000 miles on the long axis, that's bigger than, what is that, the series?
Oh,
That's
well,
quite large. How do they figure that? Did they do that by occultation? We certainly haven't observed it or resolved it.
That's an
Series.
estimate based on albedo, I think. And there's
Oh, okay.
also there also I know there have been opportunities for occultations. I don't know if anybody's had a
Oh, okay.
positive.
Can I ask one question that I never got out on Friday night at the end of Dr. Ito's speech? I've asked Tom or her to call up that big circular, actually oval map that's been made of the background radiation and the modeled yellow and blue. How is that used? Do you know where you're looking at? Can you use
Yes.
it in any way to say, oh, here it's pink, it's yellow here. So
Yeah,
it's
it's like a map of the Earth
Yeah.
when you spread it out. It's just a different projection than we usually use.
but has anybody ever superimposed the stars and galaxies and
Yes. Yes,
Kuiper
and
cloud?
the areas that are blue there are higher density, and those are where you find galaxy clusters.
Oh, it's not a temperature thing. I thought it was
It
temperature.
is a temperature thing.
It is temperature, yeah.
Okay, but the temperatures are just barely above zero.
No, they're the delta, the variation in temperature is on the order of 10 to the -4 degrees Kelvin.
yeah.
I always thought that was a map of the universe. It's not, is it?
Yes, it
It
is.
sort of
Oh,
is,
yeah.
yeah.
Oh, yeah. Yeah, too.
Okay.
Just like when you go to the planetarium at the museum, they're projecting on the ceiling, and that's a map of the universe.
Right.
It's the
And Tim,
near universe, but it's
Supposedly
the
down in that map, Ronnie, down in the right lower hand corner, the blue, there's a cold spot that they detected. Now it looked the same to me, but they claim that there's a cold spot there. And so the temperature is lower than the majority of the entire map.
right,
yeah.
right.
Well,
They're
maybe that,
suggesting that maybe that indicates a place where a multiverse could open a.
That is wild speculation.
Yeah.
Well, we're doing a lot of that, and you know,
Yes, we are, and it's a
Hey,
good part
Ron.
of science.
Yeah,
Well,
Ron,
we
these are just very, very slight variations on 2.7 kelvins. Okay, very slight variations.
right.
But it's speckled, so there's changes.
And they
So
use that thing. Oh, go ahead.
that spot you were talking about, Tim, that could be a void.
No, it's cold.
It's cold.
So
Okay.
it would be a mass concentration, if anything, ultimately.
Yeah.
I would imagine a void doesn't have anything in it. It's cold.
Ron, cold is like saying it's more dense in some sense.
Oh, it's not a temperature cold.
It is, yeah.
Oh, yeah, yeah.
The whole damn thing is cold,
Yeah.
just that some parts are not quite as cold as
Really
others.
cold.
Boy,
Okay,
that was
So,
pretty
the
fun.
way that whoever asked how do you use that, the way you use it is just what she was talking about. You do a spatial, it has spatial information in it, the distribution of sizes. and she does a Fourier transform on it, and she gets this distribution, which is that curve that you saw. I don't have one to point at.
She was calling it the power spectrum.
Yeah, power spectrum. And that power spectrum, you can calculate it from certain aspects of the Big Bang theory, and it fits very well on almost all of it. But they're trying to get, but it's a barrier. You can't see past this. And this is about 380,000 years after the really, really fast inflation, if the really fast inflation exists.
Right.
So they're trying to find a signature that really fast inflation ripples in gravitation that it left on the distribution of those cold spots. And that's what she's looking for.
Yeah. And Ron, the reason we have the modeling and the speckling and the reason we have galaxies and clumps of stuff is because when you go back all the way, if you try to extrapolate back from that Big Bang, from that cosmic microwave background, which is like the surface of the fireball of the Big Bang after it expanded to a certain point and became transparent. If you want to extrapolate back down into that, it shows that there was lumpiness, okay, in effect. And for it to have lumpiness, it means it had to have some point expanded faster than the speed of light to escape causality so that the whole thing wasn't in equilibrium and we didn't just have a smooth soup of stuff. And so that's why we have galaxies and lumpiness now, is that the quantum fluctuations got stuck where they were by this rapid inflation, because now one side of the universe couldn't talk to the other side of the universe fast enough to make everything a smooth soup.
One of the questions I asked Jerry in an email this morning was that when he was discussing some really interesting stuff about the singularity versus it just can you have inflation without any of that?
That's a good question. Right now, we don't see singularities. It's just that our vision stops somewhere. And so we extrapolate from what the trends were, and it goes to just simplistically goes to a singularity. But even people that are strong supporters of the expanding universe or the Big Bang do not believe that singularities actually exist. There's something else that's going to happen. Now, inside black holes is the other place where our theories sometimes are spoken of as a singularity. And I think that there's something else inside the black hole, maybe just inside, that prevents it from collapsing any further and reaching a singularity.
And that's like the whole driving idea behind quantization of space, time, matter, everything, you know.
Yeah.
That there's some bit beyond which you can't get any smaller.
I think Dr. Ito's, research is just really well designed. I mean, it's perfect. Just trying to prove inflation is a great way back.
I mean, don't forget, Alan Guth came up with this when he was a postdoc at Stanford in 1981, and he was in the shower. It turned out he was in the shower. And he came up with this idea to solve what Jen was talking about, the horizon problem. So why the universe out there kind of looks the same anywhere you look.
And that's how he got around it, by getting.
And I don't think anybody thought, geez, can we measure? Can we actually measure whether or not this thing happened?
Yeah.
Well, has anybody in science ever superimposed the actual stars and nebula and galaxies that we see over that?
Ron, that's a map of the sky. Yes.
Yeah.
Okay. Well, I'm just trying to figure out. Oh, look here! It's the Big Dipper, and it's over a blue area.
You won't see that pattern reproduced in the background there, but if you had the big map with all its bits in place, and you put the cursor at any arbitrary point in there, it would give you the right ascension and declination of that point.
Right.
And you have no idea where the point is in the sky?
Yes.
Yeah, you do.
Yes.
It's right there. The right ascension and declination.
Yeah.
Right ascension and declination are like latitude and longitude, Ron.
Oh, okay. I didn't see those. Are there lines on there? Just like
no, they're hidden. But the lines
hidden.
You can put the lines on if you want. There are maps that show it.
Oh,
okay.
Interesting.
Yeah.
I know that whenever they do a map of the world that's on a flat you know, and you've got Asia over on the right, and
Yeah, it distorts it.
it
Yeah.
really distorts it because the Arctic and Antarctica become huge. You know, Greenland becomes
Yeah.
bigger than America.
That's the
Ron.
trouble of trying to take a three-dimensional sphere and swash it down onto a two-dimensional flat
Hang
thing.
on a,
I was going to say, Ron, if you're lucky, you could point to one of those blue spots on the CMB and find your front porch eventually.
What colors are all I see are blue and yellow. There's other colors in there too, aren't there?
There's red, you know, red for the warmer sections and blue for the colder sections.
And
The
that's
V and
totally
O
an
is false
arbitrary
color.
choice.
That's right.
yeah, it's just assigned for convenience.
Mhm.
What'd you
But
say, Chuck?
I really liked her research because it's the way back. You know,
Yeah.
if she can find that inflation does exist, I mean, that's a huge leap.
Yep.
When you say inflation, that's the same thing as expansion, right?
Yeah.
Hubble-
Yeah, there's two inflations
Yeah.
in the Big Bang Theory. There's
Ooh.
the inflation that we actually see now, where everything's expanding.
Right.
But there was a super fast expansion right at the beginning that we can't see. It's hypothesized.
Right.
And it's that rapid expansion that they're trying to visualize.
Yep.
Trying to get experimental data that it exists or doesn't exist or what is there.
And Ron, to give you some scale on that, I've seen that described as in the first like 10 to the minus 36 seconds,
Yeah.
the universe went from the size of a nucleus to the size of a softball.
Yeah.
And that's expanding faster than the speed of light. And that's why we have lumpiness.
And the lumpies we're part of one. We're in a galaxy. Those are the lumps, right?
Mhm.
Yeah.
Mhm.
We might want to look into doing this as a topic since I believe this is the time of year and the exact year old Hubble climbed into the seat of that observatory telescope in 1924 in the fall, I think.
Yeah. Also, you know, Thanksgiving's coming up and we all expect inflation.
Yeah. Expansion at any rate.
Especially me. Yeah, you're right. All right. Well,
Tim, thanks, Tim.
then we get back on the night sky. Here we go.
All right. Corona Borealis.
So you can tell that from a bunch of lines.
Yeah, the crown. That's the crown. That's
Yeah, see the
ice
crown?
cream scoop, as Chuck says.
Yeah.
Yeah,
Usually it has two more stars included in the lines.
Mhm.
Okay. As opposed to the Aurora Borealis, which is something else.
Yeah,
And
this
there's
is the
also a
northern
southern
crown.
crown, Ron. I was actually looking for it last night under Sagittarius. Corona Australis. That's the southern crown.
Okay, so this is where T Corona Borealis, the nova to be, not supernova, but nova to be,
Mhm.
recurring nova is, and we're still waiting.
And it's moving into the daytime sky for us.
So we won't
That's
be
right.
able to
That's
see
right.
it.
One of those 5 stars is going to blow anytime. Which one?
It's the little
This-
green marker
see
that
the-
says T Corona Borealis.
That's
See the
it.
TCRB?
Yeah.
Little
So the
green-
crown right now, Ron, is just riding above the western horizon. You know, so like Chuck said, it's going to go into the daytime.
Oh, okay. It's going to explode, and that makes it a variable. It's not the end of life for it. It'll live again. It'll just
It's a recurrent nova. It's
It's
a
a
white
nova.
dwarf siphoning material off a companion star that periodically detonates, and it does not destroy the white dwarf.
Right.
does,
Right.
does it make those onion shells that we see lined up concentrically, like some of them every so often it explodes and throws off its outer shell? Is that
Something
we're
like
looking at
that,
here?
yeah, probably. We're not seeing it, but
Yeah.
okay?
You know, Jerry, looking at a Corona Borealis in the sky, it's too bad there wasn't a blue line connecting, what is it, epsilon and theta?
yeah.
Yeah.
Because then,
Yeah.
then, you know, you really do, when you're looking in the sky to try and find T Corona Borealis, you have to kind of go out left of an
Yeah.
imaginary blue line there.
Follow the curve around like this.
Yeah.
Exactly.
I think
Oh,
that's why,
that's good.
Tim, I think that's why they left the other lines out, is to show that you can just continue on that line.
Oh,
Right.
okay. I didn't notice
This is
that.
this
Okay,
is our Corona Borealis there.
Yeah.
This is
Variable star. Mhm.
Epsilon, iota. There's theta, beta, alpha,
which is also
Gamma,
called
and
Gemma.
Delta.
Yeah. Alpha's
That's
called
Delta,
Gemma.
the one that right.
Yeah, Delta.
Okay,
Delta.
I had it wrong. Okay.
And somehow there's a crown in there.
It's
Oh,
the
that's a
shape
crown.
of the crown.
That's a crown.
See?
Okay.
Well,
Of a tiara.
Ron, continue on up and left from where the line stops, and there's
Right.
two more bright stars. They're usually included in the line picture of the constellation, so it makes like a cup,
Yeah.
and that's the crown.
Yeah.
I don't recall ever seeing a crown in your planetarium show constellation.
Yes, it's there.
It's
yeah.
there.
There's
Yeah.
two of them.
Missed the crown. Okay.
And
Sorry.
Jerry, I mean, Ronnie, Chuck's got a really great story for the Boetes. Boetes looks like an ice cream cone, right? And he says that Hercules swung and missed, and he knocked one of the scoops on the double ice cream cone, and it's really this Corona Borealis. It's
Yeah.
the extra scoop of ice cream that got knocked off by Hercules. It's a great story.
I
Love
like
that
the
ice cream.
politician one better.
Yeah, but he's got a bunch of them.
So this down here, this purple line, that's 1 degree for scale.
Okay.
So you would have to go over about 2 degrees to get to Corona Borealis along this line.
Oh, okay.
And that's about the size of a low power eyepiece field of view. So if you want to star hop, you move over 1 field of view to get there, and then 1 field of view here, and then center it up, and you're there.
Mhm.
Is the size of a thumb at arm's length, maybe?
That's about right.
Yeah.
That sounds pretty good too.
But you can't look at your thumb through the telescope. So
Well, full moon is 2 degrees, isn't it?
half a degree.
Half a
Half,
degree. Oh,
one
I-
half.
Okay.
So just go 4 full moons.
Yeah.
Yeah.
Speaking of the moon,
This is not the moon.
yeah.
It's
This is Mercury.
Mhm.
Oh,
Ooh.
So this is a gibbous Mercury. Neat little software package called Mercury Map. It has features that looks like the moon. It's interesting, but it's more of a, where the moon is made more out of a crust, Mercury is made more out of a core.
Mhm.
And because it's this gibbous phase, you can tell where it is in its orbit. It's just coming around from behind the sun.
Mhm.
It's just coming up in our evening sky now as an evening object. So
And you notice the craters look really flat, most of them, and that's because it's, basically really, really hot there, and the rocks are a little more plastic.
well, something about Mercury's orbit screwed up Newton's laws, didn't it? People said everything worked except Mercury.
That was precession, yeah.
that was its orbit, not Mercury.
Yeah, that's what I said. The
It was
orbit.
Mercury's orbit.
Mhm.
Yeah.
And what that means is that when the Mercury completes 1 full rotation around the sun, it did not come back exactly to the same space. Its perihelion moved slightly. So the ellipse rotates in space. And
Oh,
they noticed that and tried to account for it.
Right.
Newton's was about halfway there, and it took Einstein with his general theory of relativity to actually explain what was happening there.
Yeah, it's a hairy problem to solve too.
speaking of the sun, which is nearby, are you going to show us that video? I never could make it work when you sent it to us of the Atlas comet going into the sun.
I will give it a shot.
No pun
There's a
intended.
great picture of the sun on spaceweather.com today of the last month's worth of sunspots, all mosaicked onto the sun.
Whoa. How in the
Yeah.
world do you get a picture of something that bright? It would wash everything out, I would think. But
You
Yeah.
use a solar filter, just like when
Yeah.
you look at it.
Yeah. So Ron, I help out at the museum on Monday afternoons, 2 to 4. And a few weeks ago, the sun was just speckled with spots. And then a week or 2 later, not much going on. So I'm going to see what happens today, with Isla.
the spots, what does Isla have a Hawaiian last name?
No, no, it turns out she's Polish. So it was really fun talking to her about that. Komasa? Yeah.
Yeah,
Yeah.
okay.
So
That's
her dad had some Polish ancestry. So she's I tried to look up the word in my Polish dictionary and I couldn't find anything even close to it. So, but
Her last name reminds me of a kind of olive.
Kalamata.
Kalamata. Yeah, that's a Greek. That's
Yeah.
Greek.
well, I'm trying to close down a deal with an astronomer that lives somewhere else that she's working with to come to town in early March. And I'm trying
Oh,
to get, Jeffrey Bennett is his name, and
okay.
said he's been dealing with this Isla Kamasa, and I hadn't met her, and I guess she was there Friday night, wasn't she?
Yeah,
Yeah.
she was there.
She
I
was,
talked to
yeah.
her quite a bit. Yeah.
The
Yeah.
tall, slender
She
young
did a lot
woman.
of work with Phil Lubin, by the way.
Oh,
Yes,
She
yes.
helped out Phil Lubin in some measurements and stuff.
the UCSB prof that wants to send the postage stamps to.
Yes.
Yep. Yep, that's the guy.
I wonder if I could get him by now.
Yeah.
Must have
She,
died.
she
hard to
just
get.
graduated, Ron. She just graduated last.
She did.
Yeah.
Well, I got her email address. What are we looking at here, President?
Okay, we're looking at phases of Venus. We
Wow.
just looked at phase of Mercury where it is. Venus right in, where are we? We're in right about here.
Mm-hmm.
Um,
Very
so
bright.
also at a gibbous phase,
Mm-hmm.
over toward the end of December, we'll be at a half phase,
Mm-hmm.
which will be where Venus is at its greatest elongation. And then shortly after that, it'll be a crescent phase, which is where Venus appears brightest in the sky.
Huh. Why does it appear brightest?
Because it's closer.
It's
Oh,
closer,
yeah.
Tim. Yeah.
Its closeness offsets the fact that it's less completely lit.
Yes.
They compete with each other.
Mm-hmm.
Our Saturday night star parties can just about never see Venus, can we? In
It's
our
pretty
chart?
low, Ron. Yeah, it's pretty
Yeah.
low. I can see it above the ocean here at the house.
Do you need me to change this or is this washed out?
It's washed out.
It's pretty washed.
Okay.
Words Ophiuchus.
Mhm.
Okay, there's our. We should be washed out. Actually, 5 of us. Anybody know what Bruce Murdoch is doing? Why he isn't on board?
No, he was at the meeting. I said hi.
I know he was. Yeah,
He sat in the back next to me and Charles.
I got to compliment the president. He's adding more to his speech in the beginning. In fact, he even had notes like I did, and we can't mention enough names. That's important.
Yeah.
And I hope you don't mind my little show of hands. Kind of
Okay. Is this washed out?
It's not up.
It's not up yet.
Oh, sorry.
Oh,
Yeah,
that's good.
better.
That's real nice.
That's
Okay.
better.
So this is dusk. That's evening, 30 minutes after sunset. Today is the 4th.
Mhm.
And the moon here is drawn 3 times its actual size.
Okay.
So it'll be smaller, won't be this dramatic,
Yeah.
but it will be in your binoculars.
But
Yeah.
see that tonight, it's going to look great next to Venus.
Yeah, and
Oh, yeah.
last night, to be honest, it was really pretty. I wondered what that little twinkler was near the moon, up above the moon. It was Antares, I guess,
Mhm.
right?
Yeah, Mercury is down here
Mm-hmm.
at 30 minutes after sunset. It's just about ready to give up and set, but it
Mm.
will be moving up this way, the ecliptic. And Venus is moving up this way also. It's coming out from behind the sun, and this is coming out from behind the sun.
Mm-hmm.
Ah,
And this up here is Ophiuchus next to
Mhm.
Sagittarius, the 13th sign of the zodiac.
All right. Chuck's birth sign.
Yeah.
So I guess, being inside the Earth's orbit, Venus, if we ever saw Venus and Mercury with a full orb lit up, we're in trouble, right?
No, they're just on the other side of the sun.
Yeah, the sun's in the way when they're fully lit up.
Okay.
But they don't look bright at that time, brightest, because they're so far away. Not only because the sun's in the way, but they're just so far away.
Yeah. I also looked, Jerry, I looked for the comet last night, but it must be awfully weak now. I got it a few nights ago in the front yard, but with binoculars.
Okay.
It's
It's
pretty
somewhere
weak.
between 6 and 7. So
Oh, well, okay. Okay.
Suchinshan. heading back out on its 80,000 year.
So later this week, we'll be seeing this phase on our moon. This is our moon.
Mhm.
The just slightly not an exact straight line, but this is close enough for first quarter.
Mhm.
So you get a lot of good structure in here. The lunar Apennines
Okay.
over here. And I don't see Clavius up here. Got me in the dark.
Mhm.
It's the
Is that-
Apollo 11 landing
And
site.
Arzeco in the middle there?
What's that?
Is that Ptolemy's and Arzeco and Alphonsus Arzeco in the middle? Right
Here?
there?
No,
Yeah.
I don't think so.
Yeah.
I think they're here,
Yeah.
Oh, okay. Huh.
but they're a dramatic looking triplet of craters also.
Mhm.
Clavius is where they're ready to dig up the monolith, right?
That would be in Clavius.
Right.
Okay.
Back to standard time.
No, we're just showing the position of other planets. This is at 11 o'clock tomorrow night.
Okay.
So if you get tired of the politics of counting votes, you can go outside and find sanity.
Mm.
Well, I'm waiting for the real fireworks later this week.
Yeah. So this is Jupiter up here.
Denial,
Orion
denial.
is now getting up. It's a winter constellation, going to be very dramatic.
Mhm.
Gemini down here. Mars is here. Jupiter's there.
Mhm.
This is the ecliptic here.
Oh, okay. All right.
So is this what we're going to see Saturday night in the dark?
If you're up at 11 o'clock and you have a clear sky, yes.
Well,
Well,
we're
this
there-
is looking kind of east, isn't it? I mean,
Yeah.
the
Yeah,
building,
this
the
is looking
building's going to be in
east.
the way
Yeah.
of the museum, I think.
Yeah. Yeah. The belt stars, Tim, go right through the east. They rise right east.
Yeah.
Okay.
And by 11, we're out of there. They have to lock up by
Oh, that's
then.
right. That's right.
Yeah, I would really like to look at these, and to do that, I think I have to go down to the pit to get a glimpse. It's
Mhm.
just the building's just too tall.
Sure. Sure. Yeah.
Hmm.
A lot of structure in here.
Mhm.
Yeah.
Yeah. The
Oh,
Great
quite-
Nebula in Orion, M42.
You know, I
Said
always
nebula.
forget the names of the belt stars. You know, the Alnitaka, Alnilam, and Mintaka. I
Mhm.
never can remember those.
Those are the three in the belt.
Yep.
Yeah. They're all
This one always
related
reminds me of the Harry Potter series.
to-
Yeah.
Do we try
A lot
to?
of those,
I'm sorry. Go ahead.
a lot of those names were, a lot of the Harry Potter names were from stars.
Yes.
Is that right?
Yeah, Sirius Black,
J.K. Rowling stole from.
Bellatrix Lestrange.
Okay.
Yeah, quite a few.
But just out of curiosity, for my own edification, because I sit up front and greet people at star parties,
Huh?
we have what, about a dozen machines set up behind me, and is everyone on a different star, or do they double up and many watching the same thing?
It's random.
It changes.
You don't agree on anything? Well, you take Jupiter tonight,
We used to try that. I used to hand out sheets for people and tried to do a theme for the night. Like for August, it was birding because we had Cygnus and we had, Alberio, a bunch of things. But people just went on what they like to look at. So I gave up on that.
well, there's a possibility everybody'd be on the same one.
Absolutely. Especially early on. Everybody's on Saturn or on the moon,
Mhm.
Yep.
Tell the visitors, I'm sorry you've seen this already 8 times, but take a look. It's the same one. You can see Saturn's rings in every telescope.
Well,
In
every
March,
view's
you
a little
won't see
bit
them.
different, we tell people. So,
Hey, there's a scar on Mars.
There's a nice valley on Mars there.
Yeah.
But the point of this is that Mars is coming closer to Earth now, coming close to opposition. It's about halfway there. The Mars is about 9 seconds of an arc across. And so it's getting big enough that you can start to see features with our size telescopes on it, provide the weather and the sky and the wind permit it.
Yeah.
So
which is
these are-
rare here.
Yeah, these dark features, as opposed to the lighter features, these coloration differences, that's what you'll see with our scope. Some with our larger scopes and clear conditions, you can see these volcanoes over here. So this is the start of the period where you stand a chance of seeing features on Mars.
And this
It
was
has
one of the hints that there was water on Mars, that there was ice under the surface, because on the left of the Valles Marineris there, you can see that what's called chaotic terrain. And that's on Earth, you see that when ice, like permafrost, melts and the ground collapses above it. And then you see all kinds of flow patterns, like the water from that flowed down through this valley and then out on the far right.
Well, I got to tell you, gentlemen, depending on how good or how powerful the telescopes were over 100 years ago, I can see why, if that's what they saw, they thought there was a canal or two on Mars.
Well, the features on Mars the canals did not come from features on Mars. The canals came from their eyeballs.
So they didn't see this, what we're seeing. It's what is a straight line
No,
Grand Canyon.
it's a general feature of the way the human brain handles information. It's the only instrument that actually really sees things that aren't there. So, and you can see it consistently, and other people can see it. It's generalized in our belief systems. We actually can believe things that are lies. And the reason for that is we evolved it to stay safe. We tolerate false positives, but false positives can lead us to all sorts of crazy conclusions. The next step on that is politics, and we're not going to get into that. So anyway, when Mars reaches its opposition, not this opposition, but in some of the big oppositions like 2003, and I think it was 1956, the planet is actually 25 seconds of an arc across. Jupiter frequently gets to 50 seconds of an arc across. So for Mars to be that big, you can see a lot of features on it. You can photograph a lot of features on it. The opposition coming up next year is not going to be that big. It's going to be around 15 arc seconds across, I believe, or a little above.
For 2003, we had people in the club sketching Mars. They observed it to see if we could get a consistent map of the surface that jived with the real features on Mars. And some people did really well.
Huh.
Yeah,
I went to.
I sketched it. I didn't know about that, Chuck. I did sketch it.
Uh-huh.
Yeah.
In 2003, for the opposition of Mars, I went to a bed and breakfast in Taos, New Mexico, called Adobe and Stars.
Adobe and Stars.
And I had my NP 101 teleview. Mars was stunning.
Yeah.
We had so many people. We did an observation, a public observation at Ealing's Park.
Yeah.
And we had so many people show up that they were parking. I mean, it was thousands of people, and they were parking along Las Positas and walking in.
Wow.
So the CHP and the fire department actually came and shut everything down. We had 23 telescopes set up.
Wow.
That's how our star parties used to be, Ealing's Park.
No,
That was
that was just a one-off.
That was my first public star party. And I turned to Chuck's wife, Pat, and I said, "Are they all like this?"
Yeah.
And she said, "Yeah."
Well, frequently there was food.
Yeah.
Well, since you got the picture up, Mr. President, are there any now you changed it. Are there plans to land in that giant Martian Grand Canyon?
No.
I'm not aware of future plans.
That would
take so long from the planning stage to the funding stage to the launching stage. I only casually keep aware of that. I get more excited when they're in the launching phase.
All right, but do they know the delineations, the dimensions, how deep, how wide we're looking at?
we have a better map of the topography of Mars than we do of the Earth, given the
Yeah.
fact that we have a lot of it underwater.
Yes.
Okay, but this
You
this
can
thing we're
look up
looking
the
at,
US Geodetic Survey map of Mars. They have topos for everything.
what's the
Topo
name,
maps.
what's the name of this canyon we're watching? That's on,
They-
Valles
Marineris.
Marineris.
okay, is it deeper than the Grand Canyon and wider than the
Yes.
Grand Canyon?
It's 3,000 miles long. It's like 18,000 feet deep.
That's wider than the US.
Whoa.
Here's Los Angeles. Here's New York.
Wow.
Okay.
The other
And
night, Neil deGrasse Tyson was on some show, and I was listening, and they were proposing going to Mars, and he suggested that why do that? We have a lot of robotics now. Why should we have to go through all the logistics of landing a live person there when we can just send robots?
It's so much more expensive to keep people alive on a mission
Right,
because you have to have so many redundant systems.
right.
plus, they never really end up touching anything. They're still inside a compressed suit. So
Yeah,
why
well,
the same?
it's really more political than anything else. As far as the robotics go, we can do everything we need to do with that.
Well, people are more flexible if you find something that you hadn't planned for, but yeah, robotics are so much cheaper and safer.
Yeah.
My understanding is if we colonize Mars, those people on Mars can never come back or their bones would not hold America, the Earth's gravity.
If we get to that stage in technology, I'm sure we can build an exoskeleton for them to move around in.
Well, clarify one thing. You told Tim Crawford earlier that opposition means it's on the other side of the sun from us. Is that what you're meaning by?
No, it means it's in the opposite side of the sky from the sun.
So we're in the middle.
Oh, okay. So on the same side as us then, as our part of the orbit. Both
Yes.
orbits on the same side of the sun, not opposite the sun.
Yeah.
Yeah.
Well,
So the line is from the sun to us to the thing that's in opposition.
okay.
Full
Doesn't-
moon, full planet.
Yeah.
But the word opposite is kind of confusing. You would think it would be opposite the other side of the sun, never mind.
It's opposite
Well,
the sky. Yeah.
The clarity that he provided really helped me a lot because I just always have gotten confused by it.
Okay. Okay, well, there's here we are on the surface.
This is a 360-degree panorama. The thing over here, this belt going up, it's going up to this thing here. So this is fully all the way around. You could wrap this around in a cylinder and put your head in it and turn your head and see all of Mars. I think it's something about 980 individual frames put together, pasted together, taken from the Perseverance rover.
It's relatively dust-free looking too.
Yeah. Yep.
Where do you suppose the little Ingenuity helicopter is nowadays?
It's a wreck sitting somewhere.
Oh, really? Oh, I didn't know that.
I thought they had gotten it going again, even though
one of the rotors broke, so they can't get going.
Yeah, they had two rotors going opposite directions so that it wouldn't spin the craft around, and they have to go like a blur because of the light atmosphere on Mars.
Yeah, it's so thin. Now Perseverance is leaving these little droppings behind as it goes along. And the plan was to send another rover up and pick them up, provided you could find them.
Yeah.
What's that?
Providing you could find them if the big dust storm comes, look out.
Yeah, that's exactly right. So, and I don't think they have beepers on them. But I don't know why they just didn't leave them on the Perseverance. And then the other rover just has to find Perseverance, which is an easy part of it.
Good point.
But they've changed that because of the success of the Flyer. What is that called on Mars? The name of the helicopter? Does anyone remember?
Ingenuity.
Yes, that's right. So they're going to build a larger cargo carrying Ingenuity, and it's going to go around and pick these up and then take it to a rover or to a station that has a return vehicle ready to go to bring it back to Earth.
So we're
But
looking,
the funding for that is so uncertain. These may be artifacts that future scientists may dig up as they're exploring Mars.
so what is it doing? Drilling a core
It
sample?
gets the sample somehow. It scoops it up or drills it up or picks it up and puts it in these ampules.
Okay, those are 10 separate capsule, whatever, containers lying on the
Yes.
surface of Mars.
And this
You know,
was
Jerry, they probably left them there so that they knew the location.
Yeah. Yeah, they have caches that they put
yeah.
bunches of them in.
These pictures were each taken immediately after depositing the modular, the capsule.
Wow.
So it may be covered up by now. Who knows?
Yeah.
Fascinating. Don't recall seeing that picture. I guess this was in your talking points and I just scrolled right by it, I guess.
I sent out an updated talking points on Sunday, and that had these pictures in it.
Yeah.
Oh, okay. Well, I usually can't find what's different in your new updates. Fascinating stuff.
Hey, just a minute.
Gonna be able to make it out to the Taurid meteor shower or variable star Mira, perhaps, before we're out of here.
I think
Great. Great. What?
I think I removed myself from the meeting.
Uh-oh.
We still see you.
We're
You
still
can?
there.
Okay, good. I can't see you guys.
Oh, must have clicked on that little white box I saw earlier.
Uh-oh. So anyway, yeah, I can't share because I don't have my screen available.
You can't see what the pictures are you're sending us?
I can't see anything.
Oh,
My
dear.
screen is completely local.
I thought we were gonna make it without any major problems.
No, not with me on board.
Well, I guess we can just talk for about 8 minutes.
What if I go and to meeting settings and then can't do that? There's supposed to be a way of me taking the becoming a host.
Well, Tim, you're showing up as the same user as Jerry is, so you're not signing in individual like we are somehow.
Mhm.
Well, usually when I join, it says, assume that the shared host or become the host.
Okay, I'm back in.
Okay, good.
You're echoing though,
Oh, shit.
and we got a new recording in
No,
progress.
no. Let me get. Okay.
One problem solved, another one introduced.
Do I still echo?
Yep.
Yes, I do.
It could just be God talking to us from space if you want.
Huh.
Are the rest of us echoed? Am I echoed?
No.
No, I don't hear it.
Not too bad, Jerry.
Huh.
We have time to get those other things, Mira, the star, or that big giant telescope built back in 1900 that didn't get used.
Okay, Chuck, I'm going to assign you as host.
Okay.
We'll just call up the pictures then.
Do
All right.
Can you hear me?
Yes.
Okay.
What do we want to look at next? Myra or
Yeah, Myra.
okay, let's go there.
Oh, it's not the Spanish word Mira.
No,
Okay.
Latin.
Okay. All right, folks. Please stand by. Here we go. Aha, the talking points.
Okay, now I'm getting Zoom is getting more and more obnoxious, and they're sitting here trying to bypass the system private window picker and directly access my screen. And it's like, no, go away. So I don't know what you guys are seeing.
We're seeing the hand that's up with the little red dot. And
I know. And like, there's no way to get rid of that apparently.
open
without
open system settings, maybe?
Yeah, I don't want to do that. I don't want to allow this
Okay.
for
Nice.
even 1 month. And it's like, go away.
AI is fighting us. There we go.
No, it's not AI, it's intrusive applications.
Mm.
Well, I'll go to system settings and then just dismiss it and see if that gets rid of everything. Okay. There we go. Are you seeing the
Yep,
the
yep,
text and
yep. You're there.
Green
okay.
clear.
You're clear.
All right, Jerry, fire away.
See, I don't see Jerry now.
We
Chuck.
lost Jerry. Okay, Jerry's gone. All right. So anyway, in Cetus, which is
Whale.
rising fairly early now,
Mhm.
there's this star right about in the middle of it that people could see and then not see. It would come and go, and so that was a big mystery. So they called it the name Latin for wonderful.
Mhm.
And I'm trying to zoom in on Jerry's graphic here, but
No, you did.
yeah, but it's kind of fuzzy. You can see. But Mira's right there in the middle of Cetus the whale, Cetus the sea monster. That's a horrible line drawing of it.
But just zoom out just a tweak and it might be better.
And what distinguishes it? It's a variable. That's the one that's going to explode after 46.
No, Ron.
Well,
No, this is one that pulsates. It gets bigger and smaller, and so it's brighter and then dimmer. There, Jerry's back. Okay, Jerry, you can do the narration.
Okay, what are we up to?
We're just on the sky window picture for Myra.
Oh, okay.
okay. So is this a rare phenomenon? I think you said we've had a couple other stars we talked about that.
Yeah, it's not that rare. It's just that it's rare for somebody to have noticed it.
Yeah.
So this
Oh,
one,
is that you,
this is one that
Jerry?
gets bright enough to see naked eye. Oh, so Jerry, you're in control again, I think.
Yeah, Jerry, you're up.
Yeah, okay. So this is Myra right here in Cetus, the constellation of Cetus. And this picture shows Myra there
Mhm.
and Myra not there.
In both of my pictures.
Can you see them?
Yeah.
Oh yeah.
Okay. Yeah,
But
there's
it's not
a
there in the
Myra
lower
here.
one, Ron.
There's a Myra here, and then here there's a little V-shaped or an arrowhead right there, but there's no Myra.
Right.
The
What
word
is the date on the lower one?
oops. Wait a second. The bottom
October.
one is
2005, I think.
Yeah.
2005, 30 October. This is 2004, July of 2004. So this is about a year and a third between the two of them.
And it's like a 400-day period, so that sounds
Yeah.
right.
So a year later, it disappeared. Is that why there's only a little arrow next to the word on the lower picture?
Yeah, there's
Yes.
no star there, but it's
It
showing
got so
where the
dim
star
that you
would
can't
be.
see it.
Would this be a Cepheid?
No,
It's not a Cepheid variable. Okay.
it's a Myra class variable.
Yeah.
Oddly enough.
I didn't know that.
Tom Whittemore did a speech about Cepheid variables once. Is my
If
first
it's bright enough for us to see it as amateurs, you
Okay.
can name it after what you see and be right probably most of the time.
I just wonder why those stick figures make a whale. That doesn't make sense to me.
Oh, I give up on that. I gave up on that a long time ago.
What
Okay.
point of variability are we at right now?
What?
What point of the variability are we at presently?
You can't see it with the naked eye.
Yeah.
Hmm.
So this is from the 11th, 2011 to 2017. This is the way it goes slowly down, very quickly up, slowly down, very quickly up. That's its variability. Now we wasted a lot of time being off the air, so we'll run a teeny bit late. This is a picture of a boloid, a very light, a very bright meteor, and there is a a loose meteor shower going on right now, the Taurids, and they are characterized by a low observer rate or low population. But when they are, they can be very big and very dramatic. So if you see one, try and remember where it was and then trace the line back and see if it goes to Taurus. And it was what's that? Yeah.
That one that happened in Russia that exploded big time, 2013, is that from a meteor shower?
That was, I believe that was just a small asteroid out on its own.
Oh, okay. So what do we see? 3 or 4 of these an hour this coming weekend?
I don't know
Yeah,
that
it's a
they're
low
that.
rate.
Yeah, they're rare.
And there are
And
two
local.
of these showers in the coming from Taurus that are active kind of adjacent to each other. So
Ah, 2 branches or whatever. So there's not one radiant, it's not coming from one spot in the sky.
there are 2 radiants, but they're both within Taurus.
And that doesn't mean there were 2 comets. There was only one comet that left that
No, I
debris,
think
right?
it's 2 comets. One of them's Comet Anka. I don't know what the other one is.
I guess we're not going to be able to see the comet Atlas go into the sun this hour.
Yeah, I'm just gonna try and get that.
Oh, okay. We're going to close things out with a bang here, folks. I couldn't see.
That happened last week, Ron. So
Well, that's not the Suchinshan. That's an Atlas, right?
that's right. It's not Suchinshan Atlas. It's a different Atlas.
This is Atlas number 2.
Yeah.
So how often do they use Atlas on the name of a comet?
It depends how often the Atlas system detects comets. It's got tons of them.
But it's not the name of somebody that discovered it. There's
It's
no
the
guy
name of
named
the
Atlas.
system that discovered it.
System is Atlas.
Yeah.
Okay. Atlas, is portrayed as holding the earth on his shoulders. Isn't that the
Yeah.
mythological Grecian? All right. We're going to try, ladies and gentlemen, before we're out of here to see a comet end. Oh, is this it?
Yeah.
Dying moments.
Oh, Jerry, it's working.
Wow.
The sun is blanked out here by a disk, so it doesn't overwhelm the picture. These little dots dancing around are radiation hit from the solar wind, particles hitting the detector. And this is the comet trying to fly around the sun, and it just evaporated.
Oh,
Coming up.
So this happened on October 28th. And
Wow.
this year.
Well, that's
coming back around. There's no tail, right?
The whole thing just vanished. This
Yeah,
was
it ran out of comet.
one that was being hyped as being a Halloween comet. And then there were signs that the nucleus was breaking apart. So then they started calling it the ghost comet because they thought the tail would survive perihelion. But the tail didn't survive. So it became the nothing comet.
Yeah.
the dead comet.
Have we
There
been?
was a comet years ago that when it came around the sun, it was just the tail and it was slowing down and stopping from debris it was running into. But the comet itself, the core had evaporated.
Really?
Yeah.
That's got to be rare. Most comets just go back on out into space again. That
If they've got the poop, yeah.
very definition. Have we been following this one? Did we know it was going to
It
die?
was just showing up.
Just
We
showed
didn't
up.
know it was going to die until about, I think, 2 weeks before it actually did evaporate. Somebody said, "Oh, the nucleus looks elongated. The coma is elongated, so we think it broke apart." And sure enough, it did.
And the only reason we don't call it an asteroid going into the sun is that it did have a tail. Comets have tails, asteroids don't, because they don't have.
It's a continuum, Ron.
Yeah.
So
Well, but why couldn't it have?
It was an asteroid with a tail.
yeah. An icy asteroid.
Well, gentlemen, I hope you got your vote in. Otherwise, you got till tomorrow, and we'll do it again next week and gather together on Saturday afternoon online for the meeting, and Saturday night, I guess, an hour earlier? 7?
Yeah,
8?
7 o'clock.
Yeah.
On Saturday the 8th, I think it is.
The 9th.
Thank you. Good luck to you. God bless, or Carl Sagan bless, whatever.